Lesson 5.3, Transformations and Symmetry of Polynomial Functions continues. In this video, we will use reference points to graph cubic and quartic functions. Use the reference points and symmetry to complete the table of values for each function. Then graph the function on the coordinate plane. State whether the function is odd, or even, odd, or neither. Then graph the function on the coordinate plane. State whether the function is... That's repeating itself. Alright, anyways. Let's go ahead and do this. So, first thing we want to do is figure out what's happening to x and y. So the 3 here is our a value, where the a applies to the y value. So we're taking all our y values and multiplying by -3. So we have 0, all my x's stay the same. So we take 0 times -3, that's still 0. 1 times -3, right? 1 times -3 is -3. 8 times -3 is -24. We're going to take each of these points and we're going to plot it on the graph to the right. So I have a point at 0, 0. I have a point at 1, -3. And then we have a point at 2, -24. So right around here. Okay. Now the thing is, on a cubic function, what happens to the right of the graph is the opposite happening on the left side of the graph. So we can take these points. This 1, -3 is going to end up at -1, +3. Okay, it's reflected. And then the negative, or the 2, -24 is now at -2, +24. And so then our graph looks something like this here. So the x and y values switch to get the other points. They switch sides. And then the last thing it asks us to tell is if it's even, odd, or neither. Or odd, even, or either. Well, first of all, it's a cubic function, right? So it has an odd degree, and it goes through the origin, and it cuts the graph in the middle. So this is an odd function as well. So then that's how we do this here. So what I would like you to do is pause it, and I want you to try this one on your own, and then unpause and see how you did. Okay, so hopefully you tried it yourself, and hopefully after watching it you got it right. But if not, you can fix it. So the first thing I did was I noticed that 4 is my d, and remember that d adds to the y value. So we have 0, 4, 1, 5, and 2, 20 for our corresponding points. This is just like last chapter when we were doing the transformations. It applies the same for cubic functions. And then you'll notice that I graphed the points from the corresponding, and then I reflected it about the center of my graph, about the vertex. And so that's how I got my 2 green points across from the purple points, or maroon, whatever the color is. Then the last thing it asked is it even, odd, or neither? And well, first of all, again, the base function is even in terms of degree. So it's either going to be an even or neither. And then since the graph centers on the y-axis, it's an even function as well. And with that, that's how we use reference points and symmetry to complete the table and graph the function.